about a month ago, maybe a couple of months ago, I was at DevOps Belgium and I met this guy called Alex Gavrilescu. Was that British or was that? It was good. Okay, cool. I've been told my pronunciation of Alex's surname is very British. But Alex Gavrilescu, and Alex built this awesome tool called Backlog.md. And Alex will go through this, but it's really, really amazing to see what can be built with a very spec-driven approach. And well, without further ado, Alex is going to walk you through it. Please welcome Alex on stage.
Hello, everyone. Thank you. Thank you for joining me here. So today we're going to talk about Backlog.md, but also we're going to have the workshop session to use Backlog.md directly in one of your tasks. So let's start immediately. So who am I? I'm Alex Gavrilescu. I'm a lead engineer in Vienna, Austria. I speak Romanian, Italian, English. When you see me, afterwards, you can talk in any of these languages. I have 13 years of experience as a developer using .NET, Kubernetes, cloud, all of these things. But recently, I tried to enter the AI world, and what better way to actually learn things than building tools yourself. So Backlog.md was an idea that I had for working to manage working on my side projects. So I wanted to structure a little bit my work. And I started working on it in June. And actually, today, we might get to 4,000 GitHub stars. There are 3,990 something. So if you guys would like, make me reach 4,000 GitHub stars today, that would be cool. But yeah, so what are we going to talk today? So first I'm going to give you some context. If any one of you went to Lada's talk a bit earlier, they would have to skip this context because her introduction to AI and all of these things is more than enough. But for who doesn't work with AI every day, I'm going to put you up to date. Then I'm going to go through my journey with AI, and hopefully this resonates with you and understand why I came up with Backlog. Then we're going to talk about spec-driven AI development and why it's important, and some conclusions. And then we're going to have a break, and we're going to start with the workshop. In the workshop, I'm going to let you code whatever you want, and I'm going to come to your desk and assist you. So, the context. This is very important, not only for AI agents, as you know, but also for humans. So, we started a few years ago with code completions. You would start typing something in your IDE, and then with AI, or even without AI, it will try to autocomplete with functions from your code, or try to guess what you want to do. This was very early. Then we had the ChatGPT kind of interactions where you would copy your code, put it in ChatGPT, ask, fix my code, and then you will copy back the solution, hopefully working, back into your IDE. And this was already an enhancement of this, but what really made it work much better is the IDE extension. So this really revolutionizes how we work with AI, because you would have the AI agents directly in your code, basically in your IDE, sitting next to your files, and you could add any file of your repository, and then the agent would know about it. So in the first version, you could only ask questions, and it evolved into edit mode, and afterwards it evolved into agent mode. And agent actually evolved outside of your IDE, and they became CLI agents. The CLI agents are from what I think the next step, and what feels to be the way that developers really like to work with code, because it allows developers to hand over tasks and let agents work for minutes, hours, and in the future maybe even days, and then get back a working result. So, what are AI agents? Very quickly. So they are a system that use AI models to perform tasks autonomously and can interact with other tools, the API databases to achieve their goals. So there are a few ways to interact with the AI agents. Matt gave a very nice representation of how we're working. So we have never looking at code and just prompting all the time. And this is what we call vibe coding. You don't get great results with this. Also, even if you are a developer that knows how to code and you check every single line of code, but you always like try to get your way by just prompting, you might have you will not get too far. Then on the left side, you have more structured way of working. So if you worked on bigger projects, either in enterprise companies or like just structure your work with Scrum frameworks where you have the whole sprint planned ahead, you would probably like to achieve the same workflow with AI, and you start with the specs, what you want to achieve, and you either are the developer that checks every single line of code, or you're a project manager that just wants the result somehow working. And this is what I'm gonna talk more about. And my journey is basically this. So I started with like just prompting, and slowly I'm going towards not even looking too much at the code. I just look at the outputs of the code and move to the next task. So how was my story? Probably like a lot of people resonate with you. So just prompting, like I said, doesn't go too far. It feels like a slot machine. It feels like sometimes it's good, sometimes it's really bad, and it's very random. And with this, I achieved around 50% success rate, which in my case, it means that I managed successfully to implement a task without giving up completely. So even if I have to go back and forth a couple of times, I still consider it successfully. So then I added agent instructions where I would put all of my important information, also about the testing, how I want it to be tested, the linting, and this way I achieved around 75 success rate. It was quite an improvement, but it was not amazing, and it led me like think, what can I do better to fix this problem? And then I realized that, obviously, like I realized myself, but it was very clear from the beginning that AI models are not deterministic, and I just needed to make the process more deterministic.
But I was chatting with them earlier.
And yeah, so how to make the flow more deterministic? So for me, what worked very well is to split the big feature into smaller tasks, and each of them should fit in a context window. How many of you like to use compaction with AI agents? You like to use compaction. Okay. That's a good question. So you like to use compaction, or you have to use compaction? When you run out of context window, one of the solutions that AI agents implemented is compaction, which means basically take the whole conversation until now and summarize it, and obviously it's gonna take a bit of context window, but not hopefully the whole context window. And so you can start coding again in the same session. The problem with this is that you lose important information, because this summary you cannot control what gets carried over. Sometimes it's like just stuff that should be thrown away. And for me, like splitting the feature into smaller tasks was the solution. And coming from my like agile workflow, always mentioning the why, the what, and the how for each task. And actually, a very important step was to ask AI sort of a feedback, to ask them to write what they understood from my task, from my request. So, hey, I want to build this super fancy CLI tool to store all of my tasks as markdown. Can you create a plan to implement this? And AI would actually write it down the way he understood it, and I can verify. And this also comes from my work, professional work. Have a clear definition of done. What means that something is finished and can be merged into and pushed to production. So the solution for me was write the tasks as markdown files, reuse the same template. So I basically copied a little bit my Jira workflow that I use at work. So a description, like why are we doing this task? A bunch of acceptance criteria that have to be done in a way that you can actually test the acceptance criteria. An implementation plan, so that I usually share with the team, hey, I would like to implement this feature in this way, and I write it down. And some implementation notes that are usually like the PR notes, like I did it this way for these reasons. And saving this information as markdown files in Git allows you to just tell the agent, hey, work on this task, which is in this markdown file. This makes the loop more predictable and less non-deterministic. So the agent could read the tasks directly from the files, and they have to implement all of the acceptance criteria and nothing else. There was a point at the very beginning where Claude was just going too far ahead and tried to implement things that were not requested. And with this, I really mitigated the problems. It would have to implement only those acceptance criteria and nothing else. And the definition of done means that the agent says, like, I am done when all of acceptance criteria are done and the tests are passing. So this was a great success for me. This way I achieved around 95% of tasks being merged without throwing away the whole code. So it was nice also from the financial perspective, because I would not run out of tokens with my plans. So it was a good start, but there were some problems with this approach. So if I asked AI, hey, can you create a task for implementing this feature? Like, I want to build Backlog.md. And it will create a markdown file, but the structure might not be the one that I expect. It might not have acceptance criteria. Sometimes I had the agent completely hallucinating the structure of the tasks. And I will not be able to know which tasks are completed and which tasks are still to do. I would have to manually handle this. Like, when the task is completed, I would have to either move it to completed tasks if I still want to reference it in the future, or I'll have to delete it manually. And coming from Jira, I would miss important features like labels, dependencies, and some metadata when a task is created, priorities, and so on. So my solution was Backlog.md. This is an image generated with Nano Banana, and it was like a trend a few weeks ago to ask Nano Banana to generate an image of how your tool would look in 1995. And if you think about Backlog.md, so I will tell you now, it's a CLI tool to have a Kanban board in your terminal. This could actually have been implemented in 1995, so I think this image fits a lot. So what is Backlog.md? It's a terminal-based project management tool that's extremely effective to keep your tasks structured with AI agents. So, first of all, it's a CLI tool. And what does it mean? So, I hope everyone is familiar with at least this CLI command. Maybe some of you use Git UI tools, but probably everyone had to run this command at least once. So with Backlog.md, it's very similar. You have CLI commands, once you install Backlog.md, obviously, to create tasks, to list tasks, to edit the tasks. And at the very beginning, agents would actually use this workflow. Now I switched to MCP, and I will tell you later about it. But it was already way more effective this way. So the end result is something that looks exactly like this. This is one of the tasks of Backlog.md for fixing some MCP issues I had. So we have a front matter section with metadata. This is some standard markdown section where you can define metadata using YAML language. Then we have the task description, the acceptance criteria, and the implementation plan. So this would be written before working on the task, and the implementation notes after the task is completed, in case we want to see what happened in that task. And this is the first review step. This is important that at this point, when you ask agent to create a task from your description, from your idea, you have the first review step. And later in the workshop, I will put some emphasis with every one of you that you really check carefully what the agent thinks it has to implement from your request. So agents can easily use Backlog.md or either using CLI or MCP. So I started with agents using the CLI, and this works with basically every AI agent. But the newer ones that have MCP support, they have more enhanced commands, because with MCP you can define the schema of the commands, and the agent knows what is available and what is not available, what is required field, what is an optional field, and so on. And this was just an example. This was an example with the CLI. So for example, here Claude, I think, so I asked it to work on a task, and he immediately put the task in progress and assigned it to itself using the CLI commands. This is something that you yourself can do. So it's not like you need to use AI agents with Backlog, but it's meant for being used with AI agents. That makes everything much simpler. So how do AI agents know how to use Backlog? So when you, later in the workshop, you will install Backlog, and the first thing that you will run in your repository is backlog init command. The first thing that it asks you, apart from the name, is how do you want your AI agents to connect with the tasks with Backlog.md? And you can choose the MCP or the CLI, or you can skip, but like that's not how you would use it with AI agents. And via MCP, it will install the instructions for the AI agents to know how to use Backlog and when to use certain features of Backlog. So this init command also would push some instructions to your agent to read the Backlog workflow. So it's a very small instruction that it will be pushed on your agents.md or Claude.md that says, hey, Claude.md, this is a project that is managed by Backlog.md. For any task-related request the user gives to you, please read this backlog overview. So this is much better than using the CLI integration, because the agent can choose to read this information depending on the task that you ask. Because if you just ask, hey, can you add this line of code to this file, you don't need to create a task for it. The tasks are only for bigger, more complex features. So Claude would normally say, okay, do I need to create a task? No, then I just do it. So if it needs to create a task, then it will go read this workflow process. Obviously, this is going to consume some context window, but then it will know how to use Backlog. And I have also some nested resources also for context optimization, because I don't want Claude to know how to create task. If the task is already created, then I just need to work on it. So we have 3 additional instructions, basically, that the agents can read dynamically whenever they need to work on any of these parts. So task creation, execution, and completion. So the agents, so this is only the information how to use a Backlog, but like exactly how to run commands in Backlog. So I'm using MCP tools for this, and agents have search task, view task details, create tasks, or update tasks tools. The CLI has also a lot more commands. That's why it started to be problematic to use the CLI instructions for the agents, because as you can see here, there are quite a lot of commands. So a lot of like variations of the same command, and AI agents would have hard time to keep all of this information in their context. So the more instructions they have to work with, the less they are effective. And this is the reason why using the CLI integration is not as good as the MCP, because I only give the instructions of what they really need to use. Yeah, so it has a terminal user interface. So we will see very later, like, have you ever seen a Kanban board in your terminal? So I didn't, so I wanted to build it. So that's how it looks, a bit blurry, but later I will actually show it, how it looks. Actually, let me do it now. So this is live. So have you seen a terminal Kanban board in a slide deck actually working? So this is how it looks. Wait a second, I need to go to this screen. Yeah, so it's live. This is how this is like connected to the Backlog project. So those are all tasks from Backlog. Usual Kanban columns. You can add more columns if you have a different process, but it's very simple. It just works. And you can also like see the details of the tasks. So yeah, acceptance criteria. So let's see one task that is finished. Wait. Like here you can see Mermaid support for the web UI. I didn't get to that point yet, but spoiler, there is also a web interface for Backlog. And you can see acceptance criteria are done and the implementation notes, hopefully, yeah, what has been done in this task. So let me. All right. So yeah, there is a web interface, like I said earlier. So it's basically sort of a Jira ripoff, but like coded by me. It's running locally. So what you have to do is just run Backlog browser, and it's gonna spin off an offline server where you can manage your task. You can create tasks, and everything happens on your computer. There is no need for internet, login, anything like this. There's no database. When you edit or create a new task, it's gonna actually save it on your file system as markdown file. So it's very, very simple. And there is a dark mode, obviously. So yeah, Backlog is free, is MIT licensed, works offline. So obviously, if you want to use it with an AI agent, you need to be online. But if you want to create 50 tasks ahead of time, you can just do it either from the CLI or from the web interface. Works on any platforms. And this is a question that I get often. What if I'm working with other people on the same project? Will they see my task? Will they see what I'm doing? So the answer is yes, but you have to push your stuff. So obviously, I cannot see changes that you did in your local Git repo unless you push them. And Backlog uses a lot of Git commands under the hood to keep tasks in sync. So let me give you 2 examples. I create a new task, and this is task ID 320. And when I push this, other people will see it in their own backlog running on the same repo, as long as they are connected to the same origin. And if I put a task in progress on one of my branches, doesn't matter as long as it's pushed. Anyone from their repo, from their other computer, will see the status changed. Maybe it's in progress. It uses like a lot of like Git fetch, Git commands, magic under the hood, but it usually works. So the reason why I say it works is because Backlog.md has been written like from ground with Backlog.md, apart from the very 3 tasks. At the 3rd task, I was already having a sort of recursive way to add new tasks and have AI agents working on implementing these tasks. And basically, it evolved like this. And it was also a challenge for me to not write any code manually. So even if I know what is the solution for this problem, I still asked AI to fix it and to try to understand. Because for me, Backlog.md was more like a learning process. The only code, like files that I wrote manually, are the instructions. So how to use Backlog and when to use certain commands. And yeah, we got to almost 4,000 stars by now. I'm not sure if we're there yet, but we're very close. It was featured on the first page of Hacker News some time ago. And on Reddit, the post about using Backlog.md was very, very popular. So, but what I explained to you what is Backlog.md, and I will explain what is not Backlog.md, because I'm already anticipating some of your questions. So it's not a command center for creating and delegating tasks to agents. You can do that, but not directly from Backlog.md. So you create your task, and then you go to Codex, you go to Claude, and say, hey, work on that task. So it's not something like Conductor or Vibe Kanban. There are like other projects that I recommend if you want to have like a command center where you create tasks and they say like implement it. It's Backlog.md. It's meant to be more like a tool that everyone uses and should be as simple as possible. It's not hosted, so there is no Backlog.md resolves to my Git repo, but that's it. You have to install it on your computer. You have to run it locally, either with the web interface or with the CLI. But some people asked me recently, hey, can you expose your backlog to the internet? I'm like, you don't want to do that, because then you have like hundreds of millions of security issues, authentication, permissions, and it's going to be hell. You already have Git in place, so I assume everyone that has access to the Git repo has the correct permissions to push things, and this is how Backlog.md works. If you can push a change, then it means you have the correct permissions on this repo. What is not there yet is, okay, I need my PM, project manager, to look at the tasks. They would have to have access to the repo. So Backlog.md is not good for that kind of workflows. It runs in your repo, and it really uses the Git commands to sync between tasks, between multiple branches. It cannot work with multiple repos. And I started working on adding documents and decisions features, so not just tasks, but imagine like long-lived specs about how to do testing, how to I don't know, like what is the language patterns that we're using, TDD, BDD, whatever. You don't want to put them in a single task. You want to put them in some long-lived documents. So I started working on them. They're quite alpha, and I want to work on them in the next weeks. The goal would be to be able to reference this local documentation from your code files. So let's say you have a function that does something complex and is connected with some other parts of your repo. You can link to the Backlog.md document file that says, okay, this is how we are doing things in this way. So that's going to be next. Also, I get a lot of requests. Can I integrate this with Jira linear GitHub issues? No. So it's not meant for that. And I think if I start working on that, I will have to quit my current job to be able to support all of these features. So because Backlog.md is just my side project to learn more about AI, I cannot support all of these features. But those tools themselves are slowly adding MCP server or AI-based tools, so you could use them directly. You don't need to use Backlog.md for this. I think, like overall, the feeling I want to give you for Backlog.md is that it's nice to use it for side projects where you want to keep structure of a bigger project that you want to build, but you don't want to set up linear Jira and then have the AI agent connect to an online linear, something like this. You want to have the quickest, simplest solution possible in your repo. This is what is Backlog for. And as I said earlier, this is my side project, so I cannot provide production-grade support like I'm doing for my current job. So we're almost done with the introduction, then we will go to the workshop. So first, I want to give you a bit more information about the spec-driven AI development, and we will try to use this flow during the workshop. So what is the spec-driven AI development? Is first, you start with knowing what to build. Like, this seems obvious, but I know a lot of developers that try to understand what they want to build before even like starting prompting the AI. And this with AI doesn't work. It doesn't work very well with humans writing code. It's really bad for AI. So if you don't know what you want to build, maybe you can do iterations with AI, that's fine, and it's gonna give you the information you need. But for the spec-driven development, you want to have all the information ahead of time. So you can have product requirement document or other tools. Then you would like to create the structure for this bigger feature that you have in mind into smaller tasks. And we will do this later with Backlog.md. And when you start working on a single task, you would like to have the AI agent create a plan for how to implement this. And my suggestion would be to only work on one single task at a time, just to not fill the context window too much. Ask the AI agent to understand your repo, understand the task and the acceptance criteria, and then create an implementation plan for how to actually solve this. And then you actually review this, and this is the last step before AI writes code. So this is the right moment to do the final review before writing the code. And then the last part, if everything went right until here, in my experience, the code is always decent. Like it's not what you didn't expect, because in the implementation plan you will see that there are some issues. So this part is usually the simplest, but what is important for the code implementation is that if you see there are some issues during the implementation of the task, you can try to improve the agent instructions or the task specifications themselves and restart from scratch and not have the same issues again. And then iterate with the next task. So a recap of the flow that we're going to do today. So you start with an idea, and you will create the product requirement document. We can look into some structures that you can use, but it's very simple. You will have this structure of why, what, and that's why and the what is in the requirements, and then the agent will come up with the how. And then you will tell agent, hey, creates. So this is what we're going to do in the workshop, actually. So first you're going to start with the prd.md. This is not Backlog.md at all. This is just the simplest way to have a structured output that the agent will work, and then we'll split into smaller tasks with Backlog.md later. Now Backlog.md will come into place, and then you will split it into smaller tasks. You will review them and adjust, and basically it's going to work more or less like this. So you ask the agent to create a task. The agent will create it using the MCP or the CLI. And nice to have, if you're using an AI agent, if it can connect to the internet and research for the latest best practices, because a lot of times what the data that they have been trained on is not up to date. So if you want to use the latest Tailwind or the latest library, they can actually go on the internet and search for the latest information. Then you basically check in a task. You will create the implementation plan. The AI agent will create it for you. You will just verify. And it will be stored in the Backlog.md task itself. Also, another reason why you should not have too many tasks running in parallel, having the implementation plans for all of them at once, is because maybe you will have a feature that has, I don't know, 10 tasks. And by the time you get to the 10th task, all of the information of the how of the previous tasks is going to be obsolete, because they might change while you're working. So it's important to create the implementation plan right before the agent implements the task. Then review and adjust, and then go to the execution. So the execution is basically just, hey, Claude, please work on task number 1 from Backlog.md. And Claude would know how to read it and how to work on it. And let me have the workflow here. This is how the whole flow works. So just to work on task 1 to 3. The agent reads the task from the markdown file via Backlog.md, the CLI or MCP, and then starts writing your code. And then repeat the loop, go on with the next task. So, final conclusions. You need to know what you want to build. It's going to be very hard to verify what the agents build if you don't know what you want to achieve. Either as a project manager, either as a developer, it's similar. You also need to know how to ensure quality. So I think this flow works very well for an intermediate senior developer, because only then you can actually tell if the agents did a good job. And don't expect 100% quality. Backlog.md had a lot of bugs at the very beginning that I slowly fixed over time, but AI agents are not perfect right now, and I think it's just good to accept a good enough result and move on. If something is completely wrong or poorly implemented, you can always go back to the task, change the requirements, and start over again. And testing and linting and formatting is also very important, or like pre-commit hooks. Those things are working very well with AI agents. Right now, the human input is very, very important. So you need to do the review at the end, but you also need to do the other 3 reviews. So after the task is created and the acceptance criteria, after the implementation plan, and at the end, the code review. And especially for UI, it's very hard for the AI agent to test themselves the result of their work. So probably some of you use Chrome DevTools MCP. How many? Few, yeah. So with Chrome Web Tools MCP, you can actually have the agent spin up a Chrome instance and test the UI, but it's not perfect, and also like not everything has a web interface. Some things have a native interface, so it will not work. So I will repeat this multiple times. So 1 task per context window. I learned it the hard way. So Lada also explained this very well. So it's not just important that you have context window to work with, but also the quality of the work of AI agent degrades a lot midway. So you always want to have as little context window used as possible. And if you think that, okay, I finished the task and I still have 50% context window left, I can start a second task in the same session. Don't do this, because the chances that the second task will be done very, very poorly are very high. Also, we talked earlier about compaction. Actually, OpenAI and Anthropic multiple times on X and even on their documentation, they say they recommend to not use compaction, even though they implement the feature themselves. So they have it, but they say don't use it. So with Backlog.md, you can have easily this process where you have 1 task, 1 context window. And because it's very important to split tasks correctly, this is also like a project management ability that developers would have to have. So, like I said, you need to know how to split a big project or a big feature into smaller tasks. This is a human ability. This is something that AI can help, but this is something that you yourself have to review and verify that it's done correctly. And once you have problems, solve it once and solve it forever by changing the agent instructions, so agent.md or Cloud.md. This is very important because sometimes same agents would repeat the same problems. They would fall into the same issues, like maybe not writing the test correctly, or maybe Cloud deleting the test to make them pass. This happened to me many times. So you just have to update this agent instructions and just tell them, hey, don't delete tests, make them pass at whatever cost. And this will drastically improve your workflow. And yeah, so I started from just prompting and I ended up here. I think there are still room for improvement, but it's already like good enough for me to let AI agents code and finish features in Backlog.md, and then I just review the code at the end. So I think it might also help you. That's it for the first part, so thank you. Now we have some questions maybe. This is the link for the slides. And we will have also like 5 minutes break so that you can go to the bathroom, take some water, prepare your laptop for the workshop. So, question? Yes? Do we have the microphone? Yeah.
Yeah, I have a question here. I see the Backlog.md, and I don't know if that was your intention when you built it, but it looks really focused for developers. And I was wondering if there is a mode or if you thought about like making it nicer for people that don't necessarily have a technical background on it.
Actually, yeah, that's actually something that my friends that are not developers ask me, like, hey, can you help me use Backlog.md for planning marketing campaigns? This is a very common use case where people try to use Backlog.md for. So you can split, you can initialize backlog in your repo. So you need to know what is a repository. You need to know Git init or like this kind of stuff. But then afterwards, you can use the web interface for this. But to be honest, I'm not sure if this is much better than, I don't know, Trello or Asana or like, because it's more portable. So for example, Asana is more portable. You can have it on your phone, you can have it on your computer. Here with Git, you would have to have a Git client. So you would have to run backlog and your Git client on each of your devices. And for example, from your phone, you will not be able to see your tasks. So I think to get to that point, I would have to work a lot and implement probably like the SaaS version of Backlog.md, and it's not in my plans here. Yes, here.
Thank you. Yeah, super exciting talk. Sounds like we're on the same page in a lot of ways. One thing that, at least on Kiro, we spend a lot of time thinking about is when we go for kind of spec-driven dev, we do the same thing you do effectively, requirements into design, implementation, and then execution. We've actually gotten a lot of feedback from people that they want to flip the way they're thinking about, like they want to think in code first, maybe for things like refactor tasks, et cetera, where the requirement is not necessarily clear up front. Have you done any experimentation with sort of retroactively pulling your task requirements out of maybe a code diff or a patch or something like that?
So, kinda. So what I realized recently is, all of these agents use LLM-based models under the hood. LLM-based models are like autocomplete on steroids. They just, given your prompt, try to write the code from it. And the solution to this is to make them go at the very end, start from the end, and then go backwards. So you, by doing this thing with the code that you said, it's sort of like showing them the end result, like where you want to, like the end state, and try to ask them, hey, how can I get from this code to that state? So that's more or less similar to what you are saying, but yeah, once you have some code snippet that you tell them, like, yeah, it's much more efficient for them to create like the plan how to get to that state. But I didn't like concretely try to, hey, give this is the code that I would like to have at the end. Can we build specs from it? Yeah. Any other questions? Okay. No. Then so it's 1:50. Let's have. Where is Simon? Maybe 10 minutes break until 2. Yeah. So let's meet again at 2, and then we start with the workshop.
So, are you ready? Are you refreshed? Do you have the laptop and the idea ready? So, how the workshop is gonna work? So let me go to the slide here. So we're gonna experiment with the flow that I showed you earlier. So first of all, we're going to make sure that everyone has backlog installed and backlog init in their Git repo. If you have any issues, I will go around the desks and help you. Then you're going to create the tasks and try to say something to Claude. Hey, Claude, please implement this huge prompt that you have in mind with Backlog.md and split it in tasks. And I will assist you if you have any issues. And then once you have the tasks, then you will check in as one task at a time. And you will ask Claude to create an implementation plan. And if it matches your expectation, then you ask it to actually work on the code. And then you will do the code review. So let's start with the first. So let's please install Backlog. Go to Backlog.md on your browser. It's a .moldova domain, so it will work. There you have the instructions how to install it. Yeah, let's have this step first, and then once everyone is more or less ready, then you can proceed autonomously. And if you need me for anything, just raise your hand, and I will try to go around and help you if you get stuck. Okay? Good. Good luck. So I got asked, once you install and run backlog init, what's next? So what next is you open your AI agent in the same repo, and then given that you, during the backlog init, you selected correctly which agent you're going to use, the agent should know that backlog exists and how to use it. So at this point, so basically just open Gemini, Codex, Claude, Cursor, or anything in the same folder where you run backlog init. And then the agent should pick it up correctly. And then you just give to the agent the idea that you want to build and ask to split it in subtasks. So another question I got is, do I have to start with a plan.md file necessarily? No, this is just so that you don't like write a huge text directly in Claude or your AI agent. Because if you do, like, if you press the wrong button and if you submit it by mistake, that's going to be an issue. So that's why I suggested to start with a plan.markdown or whatever file, so that you can like type in it and then like do some revisions before you copy the whole plan inside the Claude instance. So I realized one of the third part is a bit misleading. So what you should not understand from this, create the tasks and then create the implementation plan for all of the tasks immediately afterwards. You should only like start working on a single task and have the agent create the implementation plan for that task, not for all of them. Because what I just see happening is that if you create the implementation plan for all of the tasks, you might change a lot the infrastructure of the previous tasks, and then the implementation plan is obsolete. So just do all of the tasks at the beginning, that's fine. But then when you start working on a single task, do the implementation plan for that task only. So I just got a crazy good idea about how to evolve Backlog.md. And let me show you something that I didn't show before that actually works with Backlog.md. So let's vibe code it. So have you ever used Codex Web? Like Codex, but like the managed by them and hosted by them? Not many, like some, okay. So Backlog also works with Codex. So because of there's no MCP integration yet here, but there is the CLI. It can just like install Backlog.md and run it. So this allows you to do something like just select here the correct repo. Okay. And select the branch and just say what task you want to build. So here the request was to add callbacks when I move a task into in progress or into done, so trigger some other additional tools that I have on my computer. So let me write it here, and then I will have Codex creating the task. Maybe I should split it into creating the task first, checking if it's correct, then I will ask it to implement it.
spinning round. You're going underground, forgetting who we were. Let's try and keep it just one more day. When love comes calling, don't look back. When love comes calling, don't look away. When love comes calling, don't look back. When love comes calling, don't look away. Take your love, throw it all around like it's nothing special, just a sound. Let me say one more thing. I don't think you realize.
Yeah, so this is just another way you can use Backlog.md actually. What I do a lot of times, I get an idea. So for me, walking my dog is like the moment where I get the best ideas. So when I'm walking my dog, obviously I don't have my laptop with me. And I just take ChatGPT app that also has the Codex web hosted Codex version on it. And I just give the idea. And then when I finish the walk with my dog, I get back. I get the PR with the task created, so then I can actually work on it. This is also like one side effects of having backlog using a CLI to create tasks. It's going to take some time. Codex Web needs to spin up a new environment, and we might not be able to see the results. But when Codex finishes, it asks you to create a PR against your repo. So I think here it's almost done. It was very fast this time, but usually it takes some time. And yeah, then you have a PR that you can start working with. Okay, so task is created. So Let me do the next step. So let me review it one more time. So allow task to define shell command callbacks in front method that run automatically when task status changes. Commands should execute when status updates are triggered through Backlog.md workflows and should be configurable as bash commands. Task from method supports. Yeah, looks okay. I mean, normally you would verify, but I'm just demonstrating the features. So create PR. And now I can review one more time, but if I merge this, this will be part of the tasks I have in my repo, so I can just log in on my laptop and say, Claude, please implement task 318. Yeah, this created a file in the backlog tasks, yeah. It used backlog itself, so you can see it used correctly the CLI because you have these markers for the sections. Because when you don't see these markers, sometimes AI hallucinates to try to create tasks, because Backlog.md is also like a way to just store all of your backlog in a markdown file. So some agents, when they don't read the instructions, they will hallucinate this part. But when you see the correct markers, it means that it went through Backlog.md CLI. Actually, I got a question a bit earlier, like why not using Cloud Web Tasks or Google Joules? None of the two works as good as Codex, because in Codex Web, you can configure your container however you want. So you can say, okay, I'm going to install Backlog.md as the first thing that when the container spins up. You can't do as much in Google Joules and Cloud Web Tasks. If you manage to do it, please let me know, because I would really like to use those other tools. But Codex is already good enough for just creating a task on the fly. Say it again? So the question is, can you use both the CLI integration and the MCP integration? I would not recommend that for the following reason. The CLI instructions, I consider them legacy. They're a huge file with all of the instructions, all of the commands that are available, and they pollute the context a lot. The MCP it's the newer approach, and the agent reads the instructions based on what it has to do. If you use both, you'll get the CLI context pollution and the benefits of MCP. I would not use them at the same time. In fact, recently, when I changed it, that if Backlog.md doing backlog init detects the CLI instructions, it will override them with the MCP instructions, which are much smaller, because otherwise you take 10% of your context window just with the CLI instructions. One thing, so I noticed that some of you start the repo, and I successfully passed 4,000 GitHub stars, so thank you very much. I didn't plan it, I didn't paid some people to start right before 4,000, but it's nice that it happened right during the workshop. Also, is anyone using Gemini 3 already? One. Because it came out during the previous workshop. I installed it, but I didn't manage to use it. So I'm curious. I'm going to come to you and see how good it is with Backlog. So we're getting close to the end. Let's have a few more, 10 more minutes of playing around. Then you can experiment with Backlog.md, afterwards, this evening, next weeks. Just a note, tomorrow I'm giving a talk about Backlog.md. It's a 20 minutes version of what we did today without the workshop and without many of the things. If you want to join, please do. You're welcome to come. But it's going to be like a light version of what we had today. So if you want to have a recap of what we did today, you can also join to the talk tomorrow. But just know that it's not something new or different than what we did today. So I had the QR code here. Unfortunately, Cloudflare broke today, and my Raspberry Pi didn't recover automatically. It's not a multi-tenant, super fancy setup. It's just a Raspberry Pi with a web server, and I have the slides also deployed there. And it needs someone to actually kick it manually to make it work. So this evening, I'm gonna have the Raspberry Pi getting rebooted, and hopefully tomorrow you will find this talk on my website here. So this will, if you can bookmark or like save it somehow, tomorrow should be working fine. All right, time's up. Thank you everyone for joining my workshop. I hope you had fun with Backlog.md. You can still find me around today and tomorrow. If you have questions, please let me know. And thanks again for coming.